please come back to again when branch number jj is equal to 3, right. When branch number jj is equal to 3, the total, look at the diagram, the total number of nodes beyond branch 3 is, that is 4, then your 5, then 6 and then 9. In the bracket this number actually branches, right, and these are the node. So, there are 4, 5, 6 and 9, there are 4 nodes. So, this is your, from the, look at the table, from the table, and from this branch sending end node, for this branch sending end node is 3 and receiving end node is 4, and therefore, M 1 is equal to 3 and M 2 is equal to 4, right, and there are 4 nodes 4, 5, 6, 9, and therefore, n j j, the number of nodes is 4. That means, when j j is equal to 3, then n j j is equal to j j is equal to 3. So, n j j is equal to n 3 is equal to 4. So, here n 3 is equal to 4 from this table, right, and therefore, you j j is equal to 3. So, you form the that your E matrix. So, E j j k. So, k is varying actually from 1 to 4 here, I am not writing, understandable. So, it is E 3 1 will be 4, that means this node, it is 4, 5, 6 and 9. So, E 3 1 will be 4, E 3 2 will be 5, E 3 3 will be 6 and E 3 4 will be 9. Here also E 3 1 is equal to 4, E 3 2 5, E 3 3 6 and E 3 4 9. Now, again when j j is equal to 4, look at the table, the branch number is 4. So, that means this branch in bracket red ink, the number inside the bracket, it is branch number. So, its sending end node is 4 and receiving end node is 5. So, M 1 is 4, M 2 is 5 and number of nodes beyond this branch is just 5 and 6. So, here is 5 and 6. So, n j j is 2, that means your n 4 is equal to 2. That means, when j j is equal to 5, n j j is equal to n 5 is sorry here, when j j is equal to 4, n j j is equal to n 4 is equal to 2. That means, E 4 1 is 5, E 4 2 is equal to 6. Similarly, when branch number j j is equal to 5, so M 1 is 5, sending end node is 5. When this is your branch number, this is the branch 5, this is the branch 5. So, sending end node is 5, receiving end node is 6. So, M 1 is 5 and M 2 is 6 and only one node beyond this branch, that is node 6, and n j j is 1 because there is only one node. That means, when j j 5, n j j is equal to n 5 is equal to 1, that means only one E element, that is E 5 1 is equal to 6. Now, come to branch 6, that is this is your branch 6, this is your branch 6, right. So, when j j is equal to 6, your sending end node will be 2, that means, this is for this branch node 2 is the sending end node and node 7 is the receiving end node. So, M 1 is equal to 2, M 2 is equal to 7 and beyond this branch only 2 nodes are there, 7 and 8. So, this is 7, 8, only 2 nodes are there, hence n j j, that is your n 6 is equal to 2. That means, when j j is equal to 6, n j j is equal to n 6 is equal to 2, that means, from this branch, right. Therefore, E 6 1 will be 7, E 6 2 will be 8, that means, E 6 1 is 7, E 6 2 is 8. Next, you come to branch 7, that means, this branch beyond this is this, come look at the table here, beyond this branch only one node is there, but its sending end node is 7, receiving end node is 8. So, M 1 is 7, M 1 is always sending end node and M 2 we have taken always a receiving end node and only one node 8. So, n j j 1, that is n 7 is 1. Therefore, when j j is equal to 7, n j j is equal to n 7 is equal to 1. Therefore, E 7 1, that E element, only one element, that is your 8, right. Come to the branch 8, that means, this branch, this is the branch 8, its sending end node is 4, receiving end is 9 and beyond this your branch only one node, that is here only receiving end side 9. So, M 1 is 4, sending end node, M 2 is 9, receiving end node for this branch and only one node 9 and n 8 is equal to 1. That means, here I have written here, when j j is equal to 8, n j j is equal to n 8 is 1, therefore, E 8 1 is equal to 9. This way you are identifying all the nodes beyond each branch and you have to put it in a your read there, I mean, you have to read those data if you write your what you call computer coding, right. So, that means how to identify nodes beyond all the branches that we have put in tabular form, but identification algorithm is also there. Instead of making the table, just reading sending end and receiving end node and branch number, it can identify, but for this course I have decided I should skip that, rather than I should give you this thing in tabular form, so that it will be easier for you to understand, right. So, this is your next stage. I mean, then you might have understood that all the nodes beyond each branch how to find out, right. Next stage, that your from equation 27, right. So, this equation actually rewriting, if you rewrite the equation, that I j j, that is the branch current, right, that is the branch current, that means capital I, that means this diagram, these are the branch current I 1, I 2, I 3 and so on. But one thing just I am telling again, that when I am writing in mathematics form, I am writing say I suffix say I 1, actually it is I 1, right. When you write I 2, it is actually I 2, right. This way I am writing in mathematics, and for coding also this way we should write, rather than I 1 I 2, right. Similarly, if you have I n total number of nodes I n b, so we should this is I n b, right. Similarly, I told you I think in the previous lecture, similarly if R 1 it is there, it is actually R 1, same thing. If it is R 2 and R 2, it is same thing, right. So, there should not be any confusion. Similarly, for x, and similarly for load P L and Q L. For example, if load is P L 2, then this P L 2 they are same thing. If it is P L 3, then it is P L 3, they are same thing. Similarly, for Q, right. So, such that there should there should not be any confusion. So, this branch current from equation to actually equation 27 we are rewriting capital I j j, k is equal to 1 to n j j, then I small I in bracket E j j k, that is because you have to identify all the nodes beyond each branch. Look how you will do this. When j j is equal to 1, we have seen n j j is equal to n 1 is equal to 8. We have seen when j j is 1, n j j there are 8 nodes, and n j j is equal to n 1 is equal to 8. Therefore, j j is equal to 1 and n 1 is equal to 8. Therefore, I 1, that is branch current through branch 1, k is equal to 1 to n 1, that is k is equal to actually 1 to 8, then I in bracket E 1 k. So, k will vary from 1 to 8, right. Details I have made it such that it will be easy for you to understand. Now, you expand this your k is equal to 1 to 8, then it will be I, then E 1 1 plus I E 1 2 small I of course, plus I, then E 1 3 plus I E 1 4 plus I E 1 5 plus I E 1 6 plus I E 1 7 plus I E 1 8. But E 1 1 already this has been explained to you, that E 1 1, E 1 2, E 1 3, all these elements have been explained, right. So, what you do, this E 1 1 2, E 1 2 is equal to 3, all you substitute here. If you substitute here, like although from the table also, E 1 1 is equal to 2, E 1 2 3, E 1 2 is equal to 4, E 1 4 is equal to 5 and so on, right. If you put it, then it will be capital I 1, that is the current through your branch 1 is equal to I 2 plus I 3 plus I 4 plus I 5 plus I 6 plus I 7 plus I 8 plus I 9. This is equation 30. That means, if you look at the branch, and again there should not be any confusion, that I in the diagram I am writing I 1, that is actually I 1, that is the load current, I 2, that is actually I 2, same thing. Similarly, your I 8, actually it is I 8, same thing, right. So, meaning is same, but when I am writing in mathematics thing, I have taken suffix, but when I am trying to explain in the computer how to make computer coding, or according to that I am writing like this, such that it will be easy for you to understand the things, right. Therefore, if you that is the beyond this branch, I mean branch, that I 1 current, find out how many including this this receiving end node of this branch, that I 2, I 3, I 4, I 5, I 6, then I 7, I 8 and I 9. This is the, if you add all this load current, this is actually your branch current. But basically if you want to make it that you will write that I1 is equal to, if you apply Kirchhoff's first law here, then do not write like this. Our objective is to sum up all the load current, that will be branch current. If you apply Kirchhoff's first law at node 2, then your I1 let me use another color, that your I1 is equal to, this is I2 plus this current going through this branch also, plus I6 plus this load current also going through this I2, right. But if you substitute I2 also, then capital I6, capital I2 is equal to what, capital I6 what, ultimately I1 is equal to, you will get all the load current I2 plus I3 plus I4 plus I6, I mean whatever is coming beyond each branch. So, in this case also, that your capital I1, the branch current of this thing current of branch 1, that is I2 plus I3 plus I4 plus I5 plus I6 plus I7 plus I8 plus I9. I think this is easy for you to understand. The way we are trying to make it, I think it will be very easy for you, right. Similarly, when for just such I mean you such that you can understand each and every step, that is why everything is written for this explanation, right. When Jj is equal to 2, when Jj is equal to 2, let me look at that. When branch Jj is equal to 2, your total number of nodes beyond this branch actually 1, 2, your 3, 4, 5, total number of branches 5 we have marked here, and they are 3, 4, 5, 6 and 9, right. So, when Jj is equal to 2, capital I2, the current of branch 2, that is k is equal to 1 to n2 is equal to 5, that is k is equal to 1 to 5, I in bracket it will be e to k, because it is your from equation 27 just now this from same equation, from this equation only you substitute Jj is equal to 2 and k is equal to 1 to n2 is equal to 5, this I mean same equation from equation 27 only, right. All these equations will be written from this equation only 27. Here I have not written any equation number. So, that means k is equal to 1 to 5, it is small I, then bracket you put e to k. Now, k you vary 1 to 5, therefore, capital I2 is equal to I in bracket e to 1 plus I e to 2 plus I e to 3 plus I e to 4 plus I e to 5, right. Now, we have seen this e to 1, all these things. Yeah, already we have explained e to 1 is equal to 3, e to 2 is equal to 4, e to 3 is equal to 5, e to 4 is equal to 6 and e to 5 is equal to 9. This all these things just we have explained. Therefore, all this number that e to 1, e to 2 put it here, then it will be I2 is equal to I3 plus I4 plus I5 plus I6 plus I9, right. This is equation, this is the current flowing through branch your 2. Now, if you look at the branch 2, beyond branch 2, this current is there I3, then I4, then I5, then I6 and then I9. So, here also we are getting the same thing I3, I4, I5, I6, I9. That is why give this in tabular form, such that it will be easy for you to understand. Similarly, when Jj is equal to 3, so from equation 27 only, that Njj is equal to N3 is equal to 4, right. That means, here when Jj is equal to 3, right. So, Njj is equal to 4, that is N3 is equal to 4 and there are 4 nodes 4, 5, 6, 9. That means, your that is k is equal to 1 to N3, that is equal to 4, I bracket E3k. Now, we expand this, it is I31 plus I32 plus I33 plus I34, right, I34. So, that means, I31 is your, here it is there, I31 is 4, I32 5, I33 6 and I33 9. So, it will be I3 is equal to I4 plus I5 plus I6 plus I9, that is the current through branch 3. That means, this is your branch 3, beyond this these are the load current, no, I4, I5, I6 and I9, right. So, I3 will be is equal to I4 plus I5 plus I6 plus I9. So, here also I4 plus I5 plus I6 plus this is equation 32, right. Next is when Jj is equal to 4, when Jj is equal to 4, branch Jj is equal to 4, there are 2 nodes 5 and 6 and Njj, that is N4 is equal to 2. So, this is your branch 4. So, this is branch 4, beyond this node 2 nodes are there 5 and 6. So, 5 and 6 and n 4 is equal to 2. Therefore, when j j is equal to 4, then n j j is equal to n 4 is equal to 2. Therefore, capital I 4 k is equal to 1 to n 4, that is equal to I e 4 k, because j j is equal to 4. So, it is I e 4 1 plus I e 4 2. So, substitute the value of e 4 1 and e 4 2, these are all integer values. So, I 4 is equal to I 5 plus I 6. This is I have made equation 33. Similarly, when j j is equal to 5, right, when j j is equal to 5, branch 5, that is j j is equal to 5 means beyond this branch only one node, that is here this branch receiving a node 1 itself load current, that is I 6, there is no other branch beyond this. So, only this current is there, that means actually I 5 is equal to capital I 5 is equal to small I 6. So, it is your only one node and n 5 is equal to 1, right, n 5 is equal to 1. Therefore, k is equal to 1, n 5 is equal to 1, e 5 k. So, I e 5 1. So, actually it is I 5 is equal to I 6. So, I 5 actually same, this is the branch current, same current is going to the load, because this is the last branch of this rather your this branch is the last branch of these lateral branches, right. That is why I 5 is equal to I 6. So, when j j is equal to 6, when j j is equal to 6, that means this side, this is your branch number 6, this is branch number 6, where there are two nodes 7 and 8. So, 7 and 8, so n 6 is equal to 2. So, when j j is equal to 6, n j j is equal to n 6 is equal to 2. That means capital I 6, k is equal to 1 to your n 6 is equal to 2 I e 6 k, that is I e 6 1 plus I e 6 2, that is basically it is I 7 plus I 2, because these are the elements I 6 1 6 2 or are explained previously, and from the table also 6 1 is 7 and 6 2 is equal to 8, right. So, this is equation 35. Now, similarly, when j j is equal to 7, this is the j j is equal to 7 last branch, beyond this branch I mean there is no other branch in any way. So, this is the receiving a node. So, that is capital I 7 is equal to small I 8, from that your from this circuit you can easily make out, right. So, therefore, j j is equal to 7, n j j is equal to n 7 equal to 1. Therefore, I capital I 7, that is sigma k is equal to 1 to n 7 equal to 1 I e 7 k, that is I e 7 1, because only k is equal to 1 to 1 element. So, capital I 7 is equal to I 8. So, from this figure also you can make out capital I 7 is equal to I 8, right. When j j is equal to 8, that is that this branch j j is equal to 8, that is this branch 4 to 9, only this node is there 9, and basically capital I 8 is equal to small I 9, right, because this is also the or beyond this branch there is no other branch, and this is the only node here. So, I 8 is equal to I 9. So, here also n j j is equal to n 8 is equal to 1. Therefore, I 8 capital I 8, that is the current through branch 8, k is equal to 1 to n 8 is equal to 1 I e 8 k, that is I bracket e 8 1, that is I 8 is equal to capital I 8 is equal to I 9. This is equation 37. That means, all these E matrix that how I ask you to put in an array, it is even the diagram is very large, this matrix you can make it easily, and this you can feed it into the computer to read this data, then no identification algorithm is required, automatically it will read it and it will try to find out the branch current, right, if of course the load currents are known, I 1, I 2, I 3, I 4 all are known, but how to compute will come, right. So, this is that all this branch current evaluation, how to do it I have shown you. Now, load flow method. Now, we have to come that how we will solve the load flow. Now, what we right. So, in this case your what you call this is your that branch current evaluation, and this one just hold on, and this one that all I 9 will, when we will take the example, algorithm is given, even the lateral branches are there, those algorithms are valid for all the things, right, whether it is a main feeder case or in the lateral branches, that your what you call this this method, this lateral branches or main feeder, whatever load flow algorithm has been explained, that is actually valid for both. So, that is why the E matrix is defined, right, such that whether it is a main feeder or lateral case, you can easily understand this, right. So, next we will come to your load flow method 2. We will take the same diagram, but we will go for another technique. These two techniques only we will learn, right. So, first you have to here previous case we have seen the complex numbers are involved, that means trigonometrical terms are coming, right. But in this case second method we will try to eliminate the trigonometric functions in the load flow studies as opposed to the standard load flow case, right. We will try to solve the voltage magnitude only, because in distribution system that variation of voltage angle starting from the substation to the tail end of the feeder, the variation of the voltage angle is very small. Therefore, we will find out some methodology where it will solve voltage magnitude, and here I mean when we will go for doing all mathematics, things are not difficult one, but just to see how things are. But those previously whatever E matrix we have made it, that E matrix is required. In addition to that, we will make another matrix called F matrix, right. These two are required, but directly you will get all the voltage magnitude. Now, first you have to understand that electrical equivalent of branch 1 of figure 2, what does it mean? This is actually suppose this is the figure, it is a radial network, right, and electrical equivalent of branch 1, I mean what is the electrical equivalent of branch 1. So, if you look into that, suppose this is actually branch 1 in this case. So, this is actually substation, in this case this is substation, here also it is substation, here also it is substation, right. This is the branch current I1 is flowing. So, I put it in bracket here, right. So, but same thing, right, suffix or I in bracket 1 same thing. So, this voltage say this is substation, this is your slack bus for distribution load flow, later we will see. This mod V1 is voltage magnitude, again and again I will not utter mod V1, mod V2 and so on, I will simply make V1 angle delta 1, but understandable that this is magnitude. So, V1 delta 1 is the angle of the your slack bus, but for our study we will assume delta 1 is 0, but that is not the case, we will take a delta 1 say. And similarly, this node 2, this is the voltage magnitude V2 and angle delta 2, this is node 1, node 2. Current flowing through this branch 1, actually this is your branch 1, this 1 and 2 is electrical equivalent. What is electrical equivalent, right? This is I1 and impedance of this branch is R1 plus JX1, right. This way you have taken, instead of R suffix 1 X suffix 1 I have put it in bracket. Now, here you have to see the what is the total load fed through node 2, that means here this is branch 1, but look this when your what you call when this current is leaving to this branch 1 to 2, when some power then flowing through this line and some is going to this load and some is also going through this branch 6, some power is some power is going through branch 2, some power is going through branch 6 and some is to the load. So, ultimately whatever comes here at the receiving end, that is actually equivalent load, that whole thing, that is why you are dividing P2 plus JQ2, that is total load fed through this node. That means, this is your node 2, that means this total load fed through this node 2 means load at this point what a power, right, at this point at the just outside of this node 2, at this point exit of the node 2, then this branch, then this branch 6 and whatever power is going to the load, right, that is actually total load fed through this node 2. That is why this is the total load fed through node 2 P2 plus JQ2. Before coming to this explanation, I will come what does it mean P2 and your Q2, right. If you see this is branch 1, then what will be P2? P2 will be total load, real power load fed through this node 2. That means, P2 will be actually load of this branch. Here I am showing I2 current, but everywhere load is there, PL2 plus JQL2, then PL3 plus JQL3 I have shown earlier in this diagram main feeder case, but here space is a problem, that is why it will become clumsy. I have just written but it is all load PL3 QL3 PL4 QL4. So, whatever loads are there beyond this branch 1, that is your PL2 plus PL3 plus whatever it is, you sum it up, right, plus the loss also you have to account. So, whatever beyond this branch, whatever branches are there, this branch, this branch, this branch, this branch, this branch and this branch, this branch, that what will be the loss, that will total load fed through the node means the load of the node 2 itself, that is load of the receiving end node itself, right, plus all the loads beyond this branch, that means all the loads beyond this branch plus all the power losses in all the branch beyond this branch, right, beyond this branch all the power losses, that is actually total load fed through your real power load fed through node 2. Similarly, when you consider the reactive power load, that is total reactive power load fed through node 2, that means that is Q2 whatever it will be, that is all the load of the your node 2 reactive load of the node 2 itself plus all the reactive load of all the nodes beyond this branch, right, plus all the reactive power losses of all the branch beyond this branch, that is beyond branch 1. This is actually branch 1, right. Here just I have marked figure 3, but this is electrical equivalent of branch 1, right. If you want, you can write this one actually electrical equivalent, right, of branch 1, right. So, that means if you know P 2 and Q 2, because loss are not known, PL 2, QL 2, PL 3 loads are known, but loss are not known. So, we have to go some iterative method, later we will see, right. So, that is actually electrical equivalent of branch 2, right. Similarly, sorry, branch 1. Similarly, if you think the electrical equivalent of branch 2, before further explanation, all this explanation, first you see how things are. Suppose if I want electrical equivalent of branch 2, that means my sending end node is node 2 and receiving end node is node 3 and total load fed through this node is P 3 plus say J Q 3. Current flowing through this branch is I 2 and impedance is of this branch I 2 plus J X 2, right. So, this is the way I showed for branch 1, this is electrical equivalent of branch 2. Now, if you think this is the electrical equivalent of branch 2, so this branch this is you forget, branch 1 you forget, this is you are taking, then what is the total load fed through this node 2. Look, as soon as you are coming to branch 2, we are leaving this, this is your behind, we will see only beyond this, that is in front, right. So, whatever P 3 and Q 3 will be, that is P 3 should be load of this node, say PL 3 plus PL 4, PL 5, PL 6 plus PL 9 plus the loss of this branch 3, branch 4, branch 5 and branch 8. Similarly, for your reactive load, total load fed through this, that means Q 3, node 3, it will be Q 3 should be load of this node itself QL 3 plus QL 4, QL 5 and QL 6 plus QL 9 plus loss of this branch, reactive loss of this branch, that is reactive loss of branch 3, branch 4, branch 5 and branch 8, that is the total your P 3 and Q 3, and then that is that your what we call meaning of electrical equivalent. Thank you, we will be back.